Hello and welcome to episode 7 of the SQL for Data Analysis series with me, James from Matador Software. Today we'll be looking at joins. We'll try and solve a real life business use case together, and we'll introduce a case statement in order to help us do that, combined with our knowledge of the join. So we'll be using this slide and then we'll move forward to live demonstrations. But what you need to know is the join operator is probably the most important tool in our SQL sort of toolkit. It retrieves data from more than one table, allows data spread, and it helps us remove redundant data from within our data model. Hugely important. We'll focus on the inner join, the left outer join, the right outer join, and the full outer join, where the inner join is going to join two tables by a specific column, and it will return records that have matching values in both tables. The left outer join returns all records from the left table and the matched records from the right table. So it may not be give you as good a quality of information back, but sometimes it'll be your only option when you need to shape data. The right outer join does the reverse logic from the left outer join. And the full outer join returns all records when there is a match in either the left or right table. Now, these are what we're going to focus on, but we're going to do this in a way that's quite intuitive and building on what we've already learned earlier in the series. So it should be quite interesting. Also worth noting, there are other joins. There's a Cartesian product or the cross join, and there are more forms of join operators such as theta join, self join, and semi join. But today we should just focus on the four joins and look at how we build on this and actually solve issues. So we'll go into the demonstration now. So I've opened up SQL Server Management Studio, got to make sure I'm within the pubs dataset there in that drop down, and we're essentially going to explore some of the tables and see what we can join. So you'll notice I've got a multi-line comment there, ignore that, and we can just start to select two tables. And you can follow along if you imported this data set with me earlier in the series in episode 2. I'm going to select all from employee from that table and select all from jobs. And we can see here if we do that, there is a common link. We've got the job ID. So you can see that those columns are going to present the same data, the job ID. So we can look to perform an inner join here, and we'll see how that looks. So we'll go over the syntax a bit. We start off as usual, select all from employee, we'll take that first table. And then we need to specify inner join. And we can say jobs, because that's the table that we want to join with employee, so that we can get the job description from the job field, because that isn't present within employee. So we need to say on, and all I'm doing here is typing the table, so employee, and then dot the column name, and I equal that to the column name and the table of the second table that we want to join. So you can see with my comments, the syntax is fairly simple. And if we execute that now, you'll see with the inner join, remember it returns all matching values in both tables. So essentially I just get, because it's quite clean data here, I just get everything stuck together. But we can look at how we can reshape that. But what we're actually going to do next is look at how we kind of visualize the other joins with some less than ideal data. So again, I'm going to select all from employee, and I'll choose another table here. So authors, and we'll pick something that's not quite easy, or the connection isn't so established. So we can see here we do have a common denominator in the last name. Now, whether that last name will be consistent or lead to any information within the authors table, that's something that we can explore here using our join. So again, if we review our inner join syntax, we're just going to say here in this specific example, select all from employees, inner join on authors, and then we need to specify with which columns and which table we want to join. So we're going to use the last name, but be cautious, because between the two tables, the last name column names have different naming conventions. You'll see the authors actually has AU underscore last name, but we can still connect them, that's not an issue. But you'll see in the inner join where it only returns matching values in both tables, we only actually get one full result. So less than ideal, but important to demonstrate the functionality of the joins. So we can look at some other joins, and this is going to be a great example of data to show how they behave. So if we select left join, you'll see as we expected, we get all the records from the left table and only the matched records from the right side. So you'll see that one full piece that we saw in the inner join, because it only returns the match values, is there, but only present on both sides for that one example. Now if we look at right join, we get all the examples from the right table and just the matched on the left. So it's just the opposite logic between the left and the right join. Now, if we use the full outer join, we'll see that this returns all records when there's a match in either the left or right table. So it's an expansion basically on the left or right where it shows the full scope. And you'll see here we get lots of null values, and it's less than ideal in this specific example. So now that we're going to build on things, we can actually choose the inner join. And let's go back to the employee and jobs, start with a nicer foundation, and we'll look at how we can sort of pad this out and actually use it effectively. Because previously, we've just been using the select all. Let's actually shape our data properly. So we can say we want to select the first name, last name, the job ID and the job description. Now you'd think that would work. Now the issue, when we execute it, is that you'll see it says ambiguous column name job ID. Well, that's because there's a job ID present in both tables that we've joined. So we need to select from which one. So we can get around that by just selecting the employee with employee.jobid. And you'll see within one table view, we've now got data from two different tables. Again, if we want to shape this further, we can say where the job description is equal to publisher, for example. And that's going to return our reduced data set and might answer our query in this example. And you'll notice that there's a slight error because I didn't get rid of a semicolon. Be watchful for that. I'm still doing it. And yeah, we can just delete that and move on. Okay, so now we can look to solve an actual mock business issue by introducing the case statement and building on our joins. So let's say we want to get the first name, last name, employee ID, where that could be the job ID, for example. There is an employee ID, but we're looking at the job ID before. The job description and years of service in the company. Then mark anyone with 30 years service or greater as due a 25% salary bonus. So how would we do that? Well, we can tackle this piece by piece. First of all, it may be an idea just to get to the foundation we were with our neat inner join. And from there, we can look to sort of actually extrapolate these key columns that we need. So previously we're looking at select all, but in real life, we're probably not going to. We're going to need specific columns. So we're taking first name, last name. I'll just take the job ID from the employee table, the job description that we joined on. And now we need to get the years of service in the company. Now, this isn't something we've covered in full before, but we can use the getDate function to get today's date and take the year from that. We have used the year function before. And then we just need to subtract that from, again, we'll use the year function to pull the year from the hire date. And we need to name it. So we'll call it as years underscore service. And if we execute that now, there we go. We can see in that final column, we've now got years serviced. Pretty easy to achieve. And now instead of having to do any guesswork, we've got that value there. So to get the greater than or equal to 30 years service and the 25% salary bonus title against that, we now need to use the case statement to achieve the rest. So you can think of this a bit like an if statement if you've used other programming languages or Power BI. But we're just essentially making a sort of calculated column here. So based on conditions. So we're saying when, and remember we can't use the virtual column name, we have to use the whole year get date minus year hire date. Saying when that's greater than or equal to 30, then, that's the action part of this, and in quotation marks because it's text, write 25% salary bonus, else we can just populate every other row with usual performance bonus only, and we hit end to X out of that case statement loop. And you always use this, or in this setting anyway, where we're adding data, we would use this after the select keyword. And if we press execute, you'll see it there. It works. It's against the correct level of service. The issue is you'll see no column name because we didn't give it one. We didn't give it an alias. We didn't use that as that we see in the first select statement. Now, where do you do it in a case statement? Well, you can just do it after this end here. So say end as bonus, we'll call the column bonus, and there we go. It didn't take us very long. We're starting to piece together what we've learned, and we've actually got some real actionable insights here that we can use, in a sort of mock business setting. As usual, if you like this content, please feel free to like, comment, subscribe, and share, and I'll see you in the next episode of this series. Thank you.